Okay, there's Aaron's demonstration circuit. There's the unchanged 555 timer. There's a 1.1K resistor there in the power lead from a fresh battery. It doesn't have to be there, that's okay. There's the MOSFET. There's the scope channel A monitoring the MOSFET drain. Here's the scope channel B across the 0.066 non-inductive current viewing shunt resistor there, but we're not even going to look at that trace. There's the power supply from the 12-volt battery, okay, and so like that. And I'm not looking at it on the Philips because, as I suspected, the Tektronix scope has a easier to fool trigger circuit. The Philips, as I have been saying all along, has a very difficult to fool triggering circuit, but the Tektronix is a little bit better. So there's that nice parasitic oscillation coming off the MOSFET, and I'm going to vary frequency pot on the 555 and the duty cycle pot on the 555 like that. And if we look at it on a different time base, you can see that I got the multiple pulses, all of that stuff. And the 555's output signal drifts in voltage, as I'm sure you've noticed, Aaron. So this is not the best circuit to be using, but I'm going to show you what I mean anyway. Now, if I turn the duty cycle to where the scope loses trigger, there you go. You get that nice band there. I don't know if you can see it on the screen. Let me turn the intensity down a little bit. Okay, so you can see the detailed bands in there. And if I go and I set my scope's trigger level, I can't resolve it. There's no way that I can catch that in any of the triggering modes that I have on my scope. Even, let's see, single sweep mode. I wonder if I get a single sweep. Single sweep mode won't even pick it up. Okay, so anyway, that is loss of triggering on the parasitic oscillation coming from the MOSFET. Now, if I did, and the parasitic oscillation is caused by the 555 timer drive, not a characteristic of the MOSFET. So if I get there to where I can display some detail in that, okay. So there's that nice parasitic oscillation. I've got the duty cycle pot turned all the way to one direction right now, and you can see all that beautiful detail in there where the MOSFET is on, and then just before it turns off, it gets into this parasitic oscillation state caused by the poor turn-off pulse from the turning off of the 555 timer's pulse. And you can see all that intricate detail in there. I hope it shows up on the screen. It's beautiful, but it's also very regular. There's some fluctuation down here at the bottom that you would pick up. You'd see some minor differences if you saw that on a single shot display. And I will show that to you. Let's see, I don't think I can get that on a higher time base there. Okay. So anyway, if I go to single sweep mode on here, and see if I can do it. Okay, is that showing up? Okay, the single sweep mode, that's one sweep of one trace of the waveform there. Okay, and on a digital storage oscilloscope, you'd see that just displayed, right? And notice that it looks the same. There aren't any differences in those individual sweeps. Every time that you see that thing flash, that's one individual sweep, so you're seeing one picture of that complicated waveform. And they are a little different. What I'm doing is I'm pushing the single sweep button. And so every time you see that flash, that's what you would see if you took a snapshot with a digital storage oscilloscope. It's no different. Okay, you might see it in a little bit better detail, and of course it would stay on the screen, but that's what you would see. Okay, so now we'll go back to auto triggering here, and now I'm going to vary the duty cycle pot on the 555 timer, and I want you to look very closely at that beautiful parasitic oscillation. Okay, and watch what happens as the parasitic oscillation actually shrinks in time. until we hit a place where the scope's trigger no longer picks it up. And boom. The scope loses trigger, and my AC offset on this scope is also not as good as some others, so the trace drops a little, but if I bring it up you can see the bands there that reflect the detail as it slides by on the lost trigger. There you go. Okay, thank you.